Hey there, kids. Welcome to another lesson. This is Module 1, Lesson 10 for Grade 5 Eureka Math. And today we are going to be subtracting with decimals. So we're using these place value strategies and we're relating to a written method. That just means that we're on our way to using the standard algorithm. So subtraction is something that fifth graders often struggle with. So this actually is one of the best things that I have ever had the pleasure of teaching to help kids figure out why this works. So let's take a look at a couple of sample problems. Hopefully you'll have the notes done if you're in my class. If you're not in my class, pause the video and write this stuff down. Let me explain it real quickly. First of all, everything is related to place value because as we look at numbers that are in specific columns, the value of the digits that are to the left are greater than the ones to the right. So when you have a simple subtraction problem and you don't have to do any regrouping, such as 5/10 minus 3/10 equals 2/10, if I have 5 and I take away 3 // that leaves me with 2. Simple problem, no regrouping necessary. Same thing if I have like number 2, multiple place value positions, 7 ones, 5 thousandths. So here's my 7 ones. These are those little handy place value discs. 5 thousandths, they're over here, but I have to take away 2 ones, 3 thousandths. So I can still take away 2 ones, 3 thousandths, not necessarily in that order. I would start over here, 3 thousandths, and then take away the 2 ones. But again, there's no regrouping needed for this problem. So it's easy. Now the challenge comes when we do have to use regrouping, but that's okay. It's going to be a very fun strategy. We're going to do the same thing over and over. So let's take a problem like 83/10, and this is how they're going to write it in the book. They're never going to just give you something really easy. They're going to mix it all up, unit form, standard form. So 83/10 minus 6 4/10. Now, just in case you forgot, 83/10 is actually 8.3 because the 83/10 has to land here in the tenths place. So when you set it up, this number here in the box is what I have to pull from, okay? So if I have 8 in the ones place, that's why writing it in standard form helps, and 3 in the tenths place, now I have to subtract 6 4/10. So using the standard algorithm, let me coach you through. First of all, I have to take 4 away when I only have 3. You cannot just flip this around. Many kids will say, 4 minus 3 is 1, and I'll say, 4 is not what you have to pull from. 3 is what you have to pull from. So what we need to do is we need to recreate the 3 so that we will have more of these pieces. And where are we going to go? We're going to go here where the place value position to the greater side, the left side, has more to share. So we go over here to where I have 8. You take 1 from this column, make it 10 over here in this column because you can. Because any number here has 10 times the value as the same digit here. So if I take 1 of these, it becomes 10 over here. Now all of a sudden, I have 13 of these discs. Notice I took 1 from the greater place value position. I like to use the little base 10 cubes if you have them. So if you take 1 from a greater place value position, and then instead of keeping it all together, you break it up into all the little pieces, then you can take away from there. So if I have now 13/10, okay, so if I have the 13/10, this is only 10, but that's the extra 10 that I have, then I can take away the 4. 1, 2, 3, 4. And that will leave you with 9 pieces left over. And so that is really what this lesson is all about, is connecting the place value strategy to the written method. Okay? There's one more problem over here that I have kind of in the warm-up, and they get a little bit more complicated in the teacher's warm-up with the kids, but if you have the opportunity to practice writing this and making another chart, it's definitely helpful because you get to have 2 regrouping opportunities. So if I have 831 thousandths, here's my 8, here's my 3, here's my 1. That's what I have to pull from, or from which I'm pulling. So then you look at this 292, and first of all, we have to take 2 when we only have 1. That's okay. Go next door, take 1, and make it 10 in the lower place value column. One of these makes 10 of these. Remove it from here and give it here. Now I have 11 of these place value discs, and so I have 11 from which to pull. Every time you put 10 over here, you will have enough to subtract, okay? Because this is only going to be a single digit. So it'll never be greater than what you would add to with that 10, okay? Even if I have only 10, I can only have a 9 down here. So you'll always have enough. So you do your subtraction, 11 minus 2. Now the 3 became a 2, so then I only had 2 left. That's okay. Go next door, take 1 from here and make it 10. And then you combine what you have left. Now I have 12. And from 12 I can pull 9 easily that makes 3. And so I pulled from here and now I have 7, but 7 is enough to take away the 2. Okay, so I took 1, I had 7 left, and then I can take 2. That is subtraction. That is the strategy. And it was worth it to take a few extra minutes to show you how to do this so that it'll make your work a little easier. So we're still using that kind of weird unit form in the beginning, and then we'll be switching to the standard algorithm where you do have to show your work. All right, so subtract writing the difference in standard form. You may use a place value chart to solve. It will be handy if you keep it close by. 5/10 minus 2/10. Yay, they gave us an easy one. So 5 minus 2 is 3. Watch out for the equal signs, just like yesterday, or in the previous lesson for lesson 9, they say, oh, you've got to write the answer in unit form and then sometimes write it in standard form. Sometimes you only write it in unit form and then they leave it, so it's kind of inconsistent. But what does 3/10 look like? It looks like that. So every time I see something like this, where I have to group a couple different place value positions, I want my students to write it in standard form. So 5 ones, you should know where the ones place is. 9 thousandths, watch out for THS. Tenths, hundredths, thousandths, that's over here. If this is all I have, I must put in my zeros to hold that spot, hold those places. From this, and I'm going to write it right over here. It's my book, I can write in it. It's your book, you can write in it. Okay, so 5 and 9 thousandths, and from that I'm going to take 2 ones. Now, are 2 ones 9 in the thousandths place? No, they're right here. 2 ones, this is the ones column. So this is where I will be doing my subtraction. How many ones are left? 3. How many thousandths? 9. I didn't touch my thousandths. So this subtraction equals how many ones and how many thousandths? 3 ones, 9 thousandths, which looks like in standard form what I put right here, because I'm showing you with the standard algorithm right here off to the side. Okay, let's do another one. 7 hundredths. Okay, so if this is my ones place, then tens, then hundreds, that goes out to the left, and I have 7 there. Then, same number, I have to go all the way to the tenths, hundredths place, 8 hundredths. That's my number. That's a really odd number. Okay, so 700 and 8 hundredths. So from this, I will be pulling 4 hundredths. So only in this column am I taking 4 hundredths away. So I still have 700ths, but I will have 400ths left. And again, if you want to write it in standard form and do the subtraction out here, that's fine, so that you can see your final answer is 700 and 400ths. Moving right along, 37 thousandths minus 16 thousandths. We have the same value, and we have 2 digits for each, but caution, if it's 37 thousandths, make sure to get into the third position over. So tenths, hundredths, thousandths. From that, we're going to be taking 16 thousandths, 0, 1, 6. When you see it lined up like this, you can see that there is no regrouping necessary. All these had no regrouping. It's nice because you're just getting used to using those place value positions. And so we're going to have only thousandths left. So how many? Subtract, subtract, and then get this. And we have 21 thousandths. And in standard form, it's 0 and 0.21. So 0.021 or 21 thousandths. Now, let's use the standard algorithm. So for these, you do have to rewrite it. This is not the standard algorithm. The standard algorithm is vertical. So write your 1.4 minus 0.7. And notice that on the very first one, we have to use our regrouping strategy. So if you need a place value chart, that one that I always have kind of handy that you guys can pull out is, your place value chart. So you can kind of keep an eye on where you're pulling from. You can put place value discs in here. I wouldn't with my pencil because it's a dry erase piece, but use that if necessary so that you can erase your work. Now let's talk through this. If I only have 4 from which to pull, and I must take away 7, I don't have enough up here. So I'm going to go next door and I'm going to take 1 away. 1 minus 1 is 0. And I'm going to hold that. Okay, I'm going to hold those 10. I'm going to hold that 1 that was together and I'm going to make it 10. Which means if I have 10 plus 4, I get 14. So my short version is to just put a 1 right in front of the 4. That's how I do that when I'm regrouping. I don't like to have to write too much. Now I have 14 in this column. So 14 minus 7, I can do that, and I get 7 left over. Decimal down. In addition and subtraction, always do Beethoven's decimal down. 0 minus 0 is 0, and I end up with 7 tenths. Okay? Next one. Write it. 91 and 49 hundredths. You've got the whole box. Take up a lot of space. 0.7. Watch out. Line up the decimals. Watch out for that. Put your subtraction sign in. What do I do with these blanks? Well, when they're on the bottom, you don't need anything. It is 0. Okay, you can fill in with zeros if you wish, if it makes you happy. And then let's do the subtraction. I have 9. Everything on the top is what you have. I have 9. I'm taking away 0. That leaves me with 9. I have 4, but I have to take away 7. Don't worry. Even though there's not enough here, there's enough here. Go next door. Take 1 away, which leaves me with 0 there. That's okay. We'll take care of that next time. Give 10. Take 1, give 10. That's what I always say. I don't know if you guys picked up on that. Take 1, give 10. So 14 minus 7 is 7. Decimal down. 0 minus 0 is 0. 9 minus 0 is 9. So 90 and 79 hundredths. Copy that. Next one. Write it out. Take up some time. Make space. 191 and 49 hundredths. Line up your numbers according to place value. 10 and 72 hundredths. And let's subtract. 9 minus 2 we can do because I have enough to pull from. That leaves me with 7. But 4 minus 7, I can't do it without regrouping. I only have 4 and I need to take 7. Go next door, take 1, give 10. Notice they keep showing you basically a lot of the same numbers across here just so you can get used to doing this, these steps. So now that I've regrouped and I have 14 here in the tenths place, 14 minus 7 would leave me with 7/10. Decimal down, 0 minus 0 is 0, 9 minus 1 is 8, and the 1 minus 0, or it just comes right down, 180 and 77/100. Let's do another one. Watch out and be careful. 7.148. Okay, watch out and be careful. 0.07. Don't put the 7 over here. Line up the decimals. Line up the decimals. You could even write that on your paper. Line up the decimals. Okay, you must line up the decimals when doing addition and subtraction. So 8 minus nothing falls right down because this is what I have. Then 4 minus 7, we know that we can't take 7 from 4. So go next door, take 1, give 10. Now I have 14. 14 minus 7 is 7. 0 minus 0 is 0. 7 minus 0 is 7. 7 and 78 thousandths is our answer. Let's do another one. Be careful. 60.91. Then we're going to subtract 2.856. Notice I lined up the decimals very carefully because these numbers are, kids will say, they're crooked. They don't line up. Kids want to have everything underneath in the same columns as other numbers, but no, 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 no. The decimals and the place value, this is the ones place, this is the ones. This is the tenths and tenths, hundredths and hundredths, thousandths and thousandths. Just because I have 0 thousandths here does not mean I can't take 6 from everything else that I had up on top. So line them up according to the decimal. Now, let's start our regrouping. It's okay. It's okay to have a 0 here. It's okay. Don't be sad. Go next door. Take 1, give 10. 0 plus 10 is 10. Now I have 10 here. See, it's okay. 10 minus 6, 4. 0 minus 5. It's okay. It's okay. Go next door. Take 1. 9 minus 1 is 8. Give 10. Now I have 10 here. 10 minus 5 is 5. 8 minus 8, I can do that and get 0. And then I have 0 on top, and I have to take away 2. That's okay. Go next door, take 1, give 10. Now I have 10 minus 2, which is 8, and 5 comes down. So you end up with 58 and 54 thousandths there. Okay? I got to start jamming right along here. 3, 61 and 31 hundredths minus 2.841. Subtract. Oh, what? I don't have anything here. That's okay. Go next door. Take 1, give 10. 10 minus 1 is 9. Move on. 0 minus 4, can't do it. That's okay. Take 1, give 10. 10 minus 4, 6. 2 minus 8, I can't do that. That's okay. Take 1, give 10. 2 plus 10 is 12. 12 minus 8 is 4. Decimal down. 0 minus 2, that's okay. Take 1, give 10. 10 minus 2. Now I have 8. 5, I have nothing to subtract, so it comes down. 3 comes down. We end up with 358 and 469 thousandths. Okay, hopefully that page is all good, like you understand it. There's a bit more on this side, and I'm going to try to whiz through it very quickly because I'm already almost at 20 minutes, and I want you guys to be able to move on, but I also want to help you with all these problems. So, first, write in standard form. Okay, write that at the top. Then subtract. Okay, very important that you write it in standard form. Let's do it. 10 tens. Well, 10 times 10 is 100. Minus 110, 1/10. 110, 1 in the tens place, and then 1/10. Look for places, yeah, these are challenging. Look for places where you can line up your decimals. Even if they don't have it here, go ahead and put it right there. We have to have it anyway because I have to have my 0 here so I can subtract. Now there's nothing next door and you might be panicking saying, what do I do? That's okay. We're going to go next door. There's nothing, nothing. I do have something here. Take 1 and each row it's going to give 10. That doesn't help me over here. That's okay. Nothing. That's okay. Take 1, give 10. That's okay. Nothing here. Take 1 and give 10. So 10 minus 1 is 9. 9 minus 0 is 9. 9 minus 1 is 8, and you end up with 89 and 9/10. So you don't have to rewrite it here. You're just doing the standard algorithm. Now what about this one? 3. From 3, I'll be taking 22/10. Now, what does 22/10 look like? Well, remember, it has to land in the tenths place, so 22/10 looks like that. And I'm subtracting. From this place, I need to take 2. And I don't have anything to pull from. That's okay. Go here, take 1, give 10. Subtract. Subtract. Done. Next one. 37/10. 37/10. It has to end up in the tenths place. Minus 1, 1, and 2/10. 1, 1, 2/10. So now we can subtract, and there's no regrouping here. This is an easy one. They gave you a break. Here's the next one. 8 1s 9/100. Watch out when they skip place value positions. 8 1s 9/100. Skip that tenths place. Minus, standard form, 3.4. What if there's nothing here? That's okay. Put a 0. Now do subtraction. 9 minus 0, 9. 0 minus 4. Don't flip it for convenience. That's not convenient to get it wrong. Take 1, give 10. Now you can subtract. 7 minus 3, 4. 4 and 69/100. Let's do another one. 5.622 minus 3/100. 3 in the hundredths place, only here. That's where your number is. But that doesn't look right when I can't anchor it to my decimal. So 0.03. Now subtract. 2 minus 0, 2. 2 minus 3. Can't do it. Don't have enough. That's okay. Go here. Take 1. Give 10. 12 minus 3. 9. 5 minus 0, 0. Decimal down. 5 minus 0, 5. 5 and 592 thousandths. Let's do another. The last of these without the word problems. 2 1s, 4/10. That's one number. And from this, I'm going to pull 0 and 59/100. Okay? And you might say, how can I do that? That looks so big. But it's really not, because it's 240/100 minus 59/100. So remember, you can rename them and make them look a little different. From this 0, I need to take 9. That's okay. Go here, take 1, give 10. Look, now I can subtract. 10 minus 9 is 1. 3 minus 5. can't do it here, but if I take 1 and give 10, now I can subtract. 13 minus 5, 8, and decimal down. 1 minus 0 is 1, and that leaves me with 1 and 81/100. So now all your standard algorithm is done, and I hope you had lots of fun practicing with the regrouping, borrowing and renaming. Always just talk to yourself, talk through those problems, take 1, give 10. Last 2 problems, let's crank through these. Mrs. Fan wrote 5/10 minus 3/100 on the board. Michael said the answer is 2/10 because 5 minus 3 is 2. Well, 5 minus 3 is 2, but is he using the correct place value positions? So let's explain it using place value. Mrs. Fan wrote 5/10 minus 3/100. Remember, if you've got tenths and hundredths, those are different place value positions. So you can't line them up just because you want to take the 3 away from the 5. I'm sorry, it doesn't matter how much you want to take that number away. It is not in that position. So you have to go to the 0 in the hundredths place for the 5/10 and regroup. So go ahead and do your regrouping. We can show the exact answer, but we really just need to explain what happened. So take 1, give 10. 10 minus 3 is 7. 4 minus 0 is 0. Decimal down, put your 0. And so basically what you want to do is you want to say, Michael did not, is he correct? No. Sorry, Michael. Michael did not line up the digits in the correct place value positions. Okay, so he lined them up incorrectly. He put the 3 in the tenths place, but it's 3/100. And finally, gonna wrap this up. A pen costs $2.09. The pen, costs 45 cents less than a marker. So which one costs more, the pen or the marker? Well, if the pen is $2.09, okay, and it costs 45 cents less than a marker, then the marker is everything the pen is, which is $2.09, plus 45 cents more. So the marker, we need to find out the cost by combining the 209 and the 45. So let's add these. Now, even though sometimes we'll be focused on a specific skill like subtraction, that does not mean that they're not going to ask you to do other operations. So we have to think. 9 plus 5, 14. Carry the 1, so we're regrouping like we did in lesson 9. 4 plus 1 is 5, decimal down. Bring down the 2, this is all money, so the marker is $2.54. Okay, now, okay, so just to go back and reread, and I do this all the time, I'll just go back and reread it. The pen costs $2.09. It costs 45 cents less than a marker, so now we know the pen cost and the marker cost. Ken paid for 1 pen and 1 marker with a $5 bill. So now we have to take the pen and the marker that we know how much it costs now, combine those to see what the total cost is. 9 plus 4 is 13. Carry the 1, and then we end up with $4.63 for both. Label everything. And he paid with a $5 bill. And so from this 5, we're going to take the 463 that everything costs together, and we're going to do subtraction. This is the ultimate practice from lesson 10. So I have zeros and I need to borrow. Go next door. Nobody's there. Go next door. Take 1. Give 10. But that doesn't help me over here, so do it again. Okay? Go next door. Take 1. give 10. Now I've got all my borrowing and regrouping done for the top. 10 minus 3 is 7. 9 minus 6 is 3. Decimal down. 4 minus 4 is 0. So the answer is use a tape diagram with calculations to determine his change. We've got our tape diagram here. We've got our calculations here. And his change would be here. And if I wanted to make another tape diagram, I could put the pen at 209. And then I could have my marker at 254. And the cost of both of those would be $463, but it's going to go right over here onto the Great Minds. The 5, and you'll get into these. I'm so sorry it's so smashed in here. The total amount would be the $5 with pen, marker, and change. And that all should add up to the $5. So click subscribe, come back again. I hope this is helpful. I love these lessons, but man, they are challenging. So I'll see you on another video. Bye for now.